Okay, I think we're about ready to get started. A couple more people coming in. Everybody's super excited to learn more about arrays? Yeah. Best object ever. I promise you, if you're not an array fan coming in, I hope you will be by the time you leave the room. You'll be telling your friends, your neighbors, your relatives, arrays. Simultaneously, the future and the past. All right, so let's get started because we want to stay on time. So hi, I'm Erin McKean. I'm a developer advocate for IBM. I also run wordnik.com and the Wordnik APIs. That looks a little small. Let's bump it up a little bit, maybe not that big. And so what I hope you'll get out of this next 30 minutes or so is I hope that you learn something about arrays that saves you anywhere from 20 minutes to 2 hours of debugging time sometime in your life. And in fact, due to a kind of, and I feel like if everyone in this room saves about an average of an hour, we're going to save like a week and a half of programming time just overall, which would be great. And also, even if you don't learn anything that is immediately useful to you in your coding life, I just hope you learn something that gives you pleasure just to know. Because I think a lot of times in programming, we try to learn things that are immediately applicable, but as Francis Bacon said, knowledge is itself pleasurable. So I hope you get a little bit of enjoyment out of this talk as well as useful knowledge. And I also wanted to give you all a warning. And I want to warn you about the frequency illusion. So something that you learn today will seem to mysteriously pop up way more than you expect in the next couple of weeks. And I have not got the power to change the universe, unfortunately. What I have changed is your brains, so you will notice arrays more often in the next couple of weeks. They aren't actually going to show up more often because you've been primed today to think more about arrays. If you hear a word today, and then hear it more often over the next couple of weeks or notice it more often, that phenomenon has its own name, which is the Baader-Meinhof phenomenon. So now that I have actually told you this kind of obscure term, Baader-Meinhof phenomenon, I predict that you will hear it again sometime soon, or at least notice it again. All right, so that's a little bit of a digression from arrays. So what actually is an array? There is, of course, a technical computer science-y definition of what an array is. And it's this: a linear allocation of memory in which elements are accessed by integers that are used to compute offsets. Very fast. Unfortunately, that's not what arrays are in JavaScript. I really enjoy reading Douglas Crockford about JavaScript because he says, this is the way things are in computer science, and this is the way things are in JavaScript. And they're very often not the same way. So, what is a JavaScript array? A JavaScript array object is a global object used in the construction of arrays, high-level list-like objects. The first couple of times I read that, it felt a little difficult to internalize. I was like, oh, it's an object, and it's kind of an array. It's an array that's an object. So the way that I have, the mental model that I have about arrays is that they're objects that wear an array hat. So they are objects that have self-declared themselves to be arrays. You know, I'm not gonna tell them that they're not arrays. They are arrays. They get to decide what they want to be when they grow up, and they decided when they were objects that they wanted to be arrays when they grew up. The arrayness of an object is kind of down to, if you want to have one distinguishing characteristic between an object and an array, arrays have length. So how do you identify an array if they're really objects underneath? So what do arrays think they are? Arrays, because they are objects, think that they're objects. So I'm running a Jupyter notebook. Has anybody used Jupyter notebooks before? So all of this is live code that is actually running. Every time I hit return, it executes in the browser. I have a version of this notebook up on GitHub. There'll be a link at the end, so you can download this and play with it. It's pretty easy to get up and installed and running. But what this means is all of this code is real, all of this code is true, all of this code will run, which I think is very important. So Arrays, if you ask them what they are, what type they are, they say they're objects. This is kind of the equivalent of asking somebody, well, you know, what do you do? And they say, I'm a human being. So if you want to know whether an array is wearing its array hat, you have to say array is array, and then you'll get the answer that you expect, true. Creating arrays, there are lots of different ways to create arrays. And probably the easiest one is to just use the array literal, these empty brackets. You get an empty array. And because it's an array, it's an object that is an array, it has a length. And the length of an empty array is, of course, 0. In ES6, we now have array from. And so this variable long string is the first line of a tale of two cities. And what we're going to do is we're going to split that into an array. It is very long. And you can see that each individual character and space and mark of punctuation is now an item in this long array. There's also the spread operator, which does pretty much the same thing. I don't know why they didn't call this the ellipsis operator. I think that would have been more fun. But just a bunch of different ways to make arrays. But here's something you should know about using the literal versus using new array. So if you want to use new array with a string, works fine. Does what you expect. If you want to use new array where the element in the parentheses is a number, weird things happen. Because it thought that it interpreted that as, you'd like to have a new array, please, that is 3 items long, and they're all going to be nulls. So something to keep in mind, this is kind of the first gotcha of this talk. I think it's a pretty interesting gotcha. If you mostly use strings and then are starting to make arrays out of numbers, this is something that might bite you. ES6 gives us array of to help fix this. You see that there at the bottom? Make that a little smaller. And you can see that does what we expect, which is give you an array of one element that is the thing in the parentheses. So we talked about how arrays are objects that have length. How long are arrays? So array length is the index of the last array element plus 1. So that's pretty straightforward. Is everybody familiar with traditional regional English ways to count sheep? Yes? So it turns out there are lots of different ways to count sheep in England because being a shepherd is a really boring job and you have to spice it up somehow. So instead of counting sheep 1, 2, 3, they have these cool alternate counting methods for sheep. I don't know if you can use them on goats or not. I've never researched this, but this is a really good Wikipedia page that I highly recommend reading. So I believe this is the sheep counting method of Yorkshire, but I'd have to go double check that. So instead of saying 1, 2, 3, 4, 5, you say yan, tan, tethera, methera, pip. I get really bored with examples that are just doing basic arithmetic, so I like to throw weird facts into my software examples. So now you know how to count sheep in Yorkshire. So now that we have our sheep array, how long is it? How many sheep do we have? We have 5. We've counted 5 sheep. You can add length to an array just by changing that value. So if we want to have space to add another sheep, we can just change that length to equal 6. Now you can see that we have a little null sheep at the end of that array. We've counted 6. However, you cannot have more than 4.29 billion sheep, or whatever else you want to put in your array, because that is too long for JavaScript. If you have 4.29 billion of anything that you want to put in an array, can I tell you about this funny thing called databases? You might want to use those instead, because you're not going to be able to store 4.29 billion things in a JavaScript array. Sorry. The index of an array, or the length of an array, cannot be negative. So you can't say, I want to be double, extra, triple sure that I've taken everything out of this array by setting the array length to a negative number. I was trying to think of how, like, what kind of use case would I have? Would I want to have a negative array? Like, I want things to have not existed back into the past, but that is not possible in JavaScript. You also cannot have a decimal index to an array. I'm thinking about making a proposal to actually make this possible so that you would get 0.1416% of whatever the next element in the array is. But right now, that will not work. You can truncate an array by changing the length of an array to something smaller. So we had 6 slots in our sheep array, and now we only have 4 because we set the length to 4. But deleting an element from an array with the delete keyword does not shorten the array. So if we take out our tan sheep, the array does not close up. It puts a null there in its place. So we've extended arrays by extending the length, and we've shortened arrays by shortening the length. But sometimes we want to put in and take out actual items and not just mess with the length of the array. We just saw delete, which lets you delete one element. And you can also add at an index just by setting the value of that index to something. So we've replaced that null that we had deleted tan for in the last example. We're putting tan back in by just setting it to the value of that index. There are better ways to remove items from an array. So you can see here you can shift. So what shift does is it takes the first element of an array and returns it to you, like on a platter. You shifted it, here you go. So we're going to shift here, get yan back, and you can see that that does not replace the element with a null, but in fact takes it off the array completely. Pop does a similar thing, but on the end of an array. So you can see here, we've got Methra, that gets popped, and now we have just 2 little sheep left. Unshift does the opposite of shift, which means it puts something back on to the front of the array, so starting at the 0 index. And shift returns you the element that's taken off. Pop returns you the element that's taken off. Unshift returns you the new length of the array, because theoretically you know what you just shifted onto the array. You don't want to hear about that again. Now you want to know how long the array is. So we can see here with push. Push returns you 5 because now we've got 5 sheep. I don't know why they used unshift. Unshift is not really an Englishy word. I feel it should have been something like glom. Like glom should have been the opposite of shift. If you do shift or pop on an empty array, you're going to get undefined because there's nothing to hand back to you. So let's show that with pop. You can be more precise about how you take things out of arrays with splice. So here what we're doing is we're taking, we've got our counting sheep array. We are going to take 2 elements starting at position 1 and save those in lost sheep. So we get tan and tethra because those are the items at index 1 and 2. Those get put into the lost sheep array. And it will take them out of our original array. So you can see now the rest of it is just what was previously at index 0, 3, and 4. You can splice to add as well. So here we are going to, as you can see, add tan and tethra at position 1. And that 0 there is what we're not taking out. We're not taking out anything, we're putting things in. And you can splice from the end by using a negative index. See here we take 1 out at -2. So starting, the last element is -1, the next element back is -2. You can push arrays together with concat. So the sheep counting goes on, so after yan, tan, tethra, methra, pip, you get sethra, lethra, hovra. Got a lot of sheep now. And by pushing those 2 arrays together with concat, we get a longer array. ToString, of course, will make an array into a string, in case you want to call all your sheep out in one long string without taking a breath. You get the same results with join, but join has extra properties where you can change the join separator. So join with no separator indicated inside those function parentheses will just do the same as ToString. It will just use commas. But here we can change it to comma and a space, so it's a little bit more readable. When you are joining or toStringing, null elements will stay null. So you can see here that null, undefined, and the empty string all kind of show up as empty, nothing, in the joined string that you get out. ESX has another way to kind of extend an array with copy within. So here we've got our laugh array, which is ha ha he he, kind of a dorky laugh. We're going to copy within that laugh array. So what we're going to do is we're going to take two elements, starting at position 0, and we're going to add it. And so what happens here is now we have an array that's all ha's, because copy within will overwrite. It will not extend. And array fill in ES6 lets you make arrays very quickly. So here we're using that integer behavior that we showed earlier, where we're going to have an evil laugh array that's going to be 25 empty slots long. And now we're going to fill it with ha, so now we have evil laughter in our array. So now we have all these arrays that are full of things, but we might want to find things inside of our arrays. So there are lots of different ways to find elements inside an array and to find the indexes of array elements. And find is kind of the basic one. So I have an array that's called tail array 1, which is a random selection of words from that Tale of Two Cities quote. It's randomized in a hidden code block here, so I don't know what's in it. And so what we're going to do is we're going to have this little function that says, okay, give me the first element that begins with the letter W, so that we get the word worst. And so you can see here, we're actually, since I know everything in this element is a string, we're treating these strings as like little arrays in themselves, so we can index the first character of those strings by treating the string as an array. If we want the index of the matching item, if we know that a word exists that begins with a W, we just want to know where is it in the array, then we can use find index, and that'll return the index. If we just want to know whether there's something in that array that meets our test, then we can just use sum. So is there any word in that array that begins with W? Yes, we just saw worst. We can say tailArray.sum, return item that begins with W, and it'll say, yes, there is a word that begins with W in this array. But if we want to make sure that every element in our array passes some test, then we use every. These are some of the names that are actually logical. Not every word in that random array of words from A Tale of Two Cities begins with W, so every is going to return false. So here's some weirdnesses with find methods on arrays. If you change your array while you're trying to find something in your array, find index, sum, and every will not find it. So here we've got this changed array. Sorry for the basic arithmetic here, we're just going to have a boring array of boring old numbers. So what we're trying to do is we're going to see what's in the array. We are going to add to that array whatever index we're at plus the number 4. We're going to see how it's changed, and then we're going to say, okay, if this item equals 4, return it. Does that make sense so far? So we can see here that we do have 4 in our array, but sum is not finding it because it's changed while it's running. So if you're going to be using arrays where you're going to be kind of using an array as a holder for a stream of things, find and sum and every and find index might not operate the way that you're hoping they will. If you change an item in an array before one of these find methods gets around to it, it will evaluate that item at the time that it's seen. So here we can say, we're going to take that array. Here, I'll show you. And you can see here that because we have set the 2 element to 0 before it gets evaluated. Oh, here, down at the bottom, you can't see that it says false. So I think really the moral here is don't screw with your arrays while you're trying to find things in them, and everything will be fine. If you know what element you want, you could just use the index of to find its place in the array. So in the Tale of Two Cities quote, worst is element 9. Index of will return a -1 if the element doesn't exist in your array. So Charles Dickens did not have access to the word whatevs. So whatevs is not in that Tale of Two Cities quote. I, for one, would have really enjoyed reading a Dickensian character who used whatevs, but, you know, lacking a time machine, I'm never going to realize that dream. So, index of will not find not a numbers. Just throws up its hands, doesn't know what you're talking about. So you can see here we've got a not a number array that has 0 and not a number. What's the index of not a number? It's not there. So not a numbers are invisible to index.of, which is an interesting property, and I do not recommend that you write anything that depends on this property. Just seems like a bad idea. Find index will find not a numbers. So I don't know why there's this difference between find index and index of in how they handle not a numbers. It's just a charming quirk of JavaScript, but it's something that you should be aware of, because if you're used to one and not the other, the behaviors are different. When you're using index of, you can give index of a number, an index to start looking at. So if you remember, we found that index of worst was at 9. Here we're going to give index of, we're going to say, hey, start looking for the word worst, but start at position 10. And that's not going to find worst because worst was at 9. We started looking at 10. This is kind of the inverse of your keys are always in the last place you look. So it will start looking after something has already been indexed. If you start that index of index at a number that is longer than your array, then you are looking outside of the house and you won't actually find what's in that array. But the inverse of this actually works. So you can give index of a negative index and it will start from the beginning of the array. And that negative index, I haven't tested this, but it could be probably up to 4.28 billion if you wanted. And that's kind of like, oh, if you really want to make sure that it starts searching the entire array, you can give it a negative index and it'll start from the opposite end. This is pretty much the only time where visualizing the number line has come in handy for me. So I really need to probably thank my 4th grade math teacher and say, yes, I'm glad I learned the number line at this point. Last index of is like an index of, but it searches from the end. So was the last instance of was is at position 90 in that very long quote. And this is the reverse of the behavior of index of, in that if you give a negative index that's longer than the length of the array, in this case it won't be searched either. So let's show that. So can't be found because it's too big of a negative index. So if you just want to know if your array includes an element, but you don't really care where it is, you can use includes. And this Tale of Two Cities quote does not include the word heaven, so we get false. So filter is a method that lets you create a new array consisting of just the elements that match your function. So here we want to get just the words that begin with a W. And sort does exactly what you think it's going to do, except, is everyone familiar with sorting according to string Unicode code points? Good, because I am a dictionary editor, and this is not how we sort things in like the normal world. So let's see what this sort looks like. So 10, of course, sorts before 2 because it has the first code. Do you see here? This 1 here is going to come before 2, even though like kind of normal people sort, we would want to sort that in integer order, and capital letters come before lowercase letters. If you would like to hear me talk about how dictionaries sort things, that is another much, much longer talk. But it's something to be aware of when you're using sort. The new set object in ES6 makes it easier to get arrays of unique elements. Who was using things like Lodash to try and get unique? Yeah, Lodash is a great library, but now we have set. So what we're going to do is an array from a new set. Sets are unique. And so now we have the unique words. And you can also use the spread operator with new set. Kind of array from and spread are, I think, technically interchangeable, but there are complicated reasons to use one or the other. Reversing an array can be done with reverse. And so supposedly reversing a string is something people get asked to do in job interviews. So here's how you do it in JavaScript. I think this is another one of those leftovers from the day when everyone was expected to be a C programmer. And reversing strings in C takes you kind of all damn day. But in JavaScript, I mean, once you write the code, it's super performant. But doing the code for strings in C is not so fun, if I remember, and did miss the time doing it. So anyway, here's how you reverse a string in JavaScript. Very straightforward. Oh, iterating. Iterating is fun. Array for each means never having to write a for loop again. So for each item, we're going to give you the item length. Remember, for each does not return anything. For each just does things. If you want to return things, then you might want to use map. Map, I think, is one of the best things about arrays because you can take every item in an array, do something to it, and what comes back to you is a new array. So here we're going to cap all of those W words. Reduce smushes an array to a single value using a function of your choice. I worked really hard to find an example that doesn't use any numbers because usually people just add numbers with reduce. So what this function does is it finds the longest word in this array by comparing the length of the current value to the length of the accumulator, returning whichever is bigger. And the accumulator is kind of just what it says it is. It accumulates a value that then you can use for comparison. So the longest word in that W caps array is wisdom. For in is another iterator, and it's kind of weird. It's weird for two reasons. One is that the order of how things happen in for in the documentation, it says it's an implementation detail of the engine. So it depends on what engine you're using to interpret your JavaScript. And also, for in is everything in the array. So if you're working with someone who modified the array prototype and just forgot to tell you, like maybe added a function or added a value that's not an integer key, then it might do super weird things like return you a function. So unless I have not yet found an example using for in that I've looked at and said, yeah, I really want to do that. Entries and keys. So for each doesn't operate on null values. Map will run on null values, but undefined will be null. So here we see we've got an array with gaps that has an empty string and then null and a couple things and undefined. So you can see when we're running for each, we only get the items with a value back and the undefined. With map, we get all the null values, if that makes sense. So map doesn't work. For each doesn't operate on null values, but map does. But entries kind of works on everything. So you can see here we're going to get each entry in this array with entries. Object keys doesn't like holes in your array. So it's not going to give you a key for a null item. And, but the keys will handle them. So you can see object keys and keys have slightly different expressions, even though they have very similar names. Values works the same way as keys, but it's not supported in Chrome, so I can't show it to you yet. So at least not in this browser. So I'm rushing a little bit to get to the end. So we got a little bit of a highlight earlier with the question. So what's the biggest array gotcha of all? Performance. So people will talk to you about when arrays are performant and when using arrays is not performant. But I can't give you an answer about when you should use arrays or when you should not use arrays because it depends on what you want to have performant. You might need to write code that runs very fast. That might be your business use case. That might be what you're being paid to do. Or you might be on a team that needs its software developers to run very fast because you're going to be writing code that needs to be easily read, easily understood, easily modified. And which one of those performance targets you need is kind of up to you and your team and your company. So I can't tell you what the best performance is because I don't know what you want to do. I'm a developer advocate. I need to optimize for code that's easy to read and easy to understand. Other people are, I don't know, splitting the atom, and they need to write code that runs very quickly. So that's something to think about. If you want to know more about arrays, there's so much more about arrays. This is the cell phone slide if you want to take a picture of things that you might want to read. I think Practical Modern JavaScript is really great for talking about these array methods. And of course, exploring ES6 is really interesting too. I also run the Semicolon Appreciation Society, so if you would like a Semicolon Appreciation Society sticker, come find me afterwards. I have plenty of them to give away. You can appreciate the semicolon from whatever distance you need to appreciate the semicolon from. If you don't want it in your code, and if you appreciate it more when it's not in your code, that's a perfectly valid way to appreciate the semicolon. I've got plenty of these stickers. So you can find me on Twitter and GitHub as Erin McKean. I will have this Jupyter notebook. It's up on GitHub now, but I made a couple expansions, so I'll push a new version tonight. Because I work for IBM, I can offer you all free IBM cloud accounts. So we now have a light account that lets you do all sorts of cool things like, I don't know, launch Kubernetes clusters and use Watson to win whatever game show Watson hasn't won yet. So with that code, you can get a free account. I think that's it. Thank you so much for your attention. I'm happy to answer questions that I can answer and try to find you answers for questions that I can't answer. So thanks again.